we're talking about gerrymandering, and I want to do one more example of sort of drawing the lines. You know, what we talked about last time was, first of all, when you look at a map, can you tell what are the possible outcomes that you can get by drawing the lines in different places, and then can you actually draw the lines to achieve those outcomes? So I have another handout to try it on. This one is not a grid like last time. This is still just totally made up, but this is I suppose, slightly more realistic example. There's one like this on the homework that you might have seen if you tried to do it already. This is a map of our dear university campus, and I have put some dots and some stars at various places around campus. And the dots and stars you should take to represent sort of two different types of people, two different political parties or something. And we're going to try to draw little districts in there to make various different outcomes happen in the election. So my picture, I think I have in here. Come on. Here. All right. So this is a map which has, I got a handout for you, a bunch of circles and a bunch of stars, and you can count this up yourself, but I will tell you we have 50 individual stars and circles. And if you count them up, you will find there's 20 stars and 30 of the circles. All right. And your job is to divide this into 5 districts of 10 each. Good morning. I want 5 districts of 10 each. I got a handout. Leave me hanging. All right. 5 districts of 10 each. All right. So it is your job to draw some lines in here to divide the map into 5 regions with 10 individual people in each one. I got a handout.
Thank you.
All right, so first question, this would be a typical homework or test question. First part would be, what are the possible outcomes that you can make happen in a map like this? So what are the possible outcomes? And actually for this question, you don't even need to look at the picture at all to answer this question. What are the possible outcomes when you divide this into 5 districts of 10 each? Can I make it, for example, can I make it so that the stars win every time and the circles win none of them? Or can I make it so that it's like 4 and 1 or so on? This is the question, all right? Maybe I'll just write down a list of, just like without doing anything, the possibilities are 5 circles, 5 stars, that's a star there, 0 circles, sorry my circle looks like a 0, it could be 4 stars, 1 circle, it could be 3 stars, 2 circles, 2 stars, 1 circle, no, 3 here, 1 star, 4 circle, or 0 stars and 5 circles, right? Now, this is not the answer to my question. I asked what are the possible outcomes. These are just just because there's 5 districts, those are the ways that it could go. But some of these are impossible, actually, based on the numbers of voters that are in there. So you have to decide for yourself which out of these are actually possible and which are impossible. And we have, I will just remind you, I already said this, but we have 30, which one was it? 30 circles and 20 stars, right? And each district has 10 voters. I hope you remember from last time. The way that you want to think about this is, first of all, decide for yourself, what is the threshold? How many voters we need to win in an individual district? Can anybody say?
6.
6, yeah. Each district has 10 voters, so if you got 5 and 5, that's a tie. If you want to win, you need 6 per district. So the threshold to win is 6 per district. And so I would ask myself, is it really possible, for example, for the Stars to win all 5? What do you think? I think the answer is no. I see some head shakings. You need 6 to win per district. So to win 5 districts, we need 6 times 5, which is 30 voters. All right, but we only have 20 Stars, so that means the Stars cannot win all 5 districts. All right, so the Star can't win all 5. All right, so that means on my little list on the left there, this is impossible, right? The Stars cannot win all 5. Can the Stars win 4 of them? Any thoughts? They can't win all 5 because this would require 6 times 5, which is 30, and there's only 20 of the Stars, so they can't win all 5. Can they win 4 of them? You got to think, how many would that require? That would be 6 times 4, which is 24. That still is too many. They also cannot win 4. So Star can't win all 5. Let me just write that also. To win 4, they need 6 times 4, because you need 6 to win each district. And this is 24. And again, that's too many. There's only 20 of the Stars. So the Star also cannot win 4. All right, so this one is also not allowed. What about the next one? Is it possible the Stars can win 3? This would require 6 times 3, which is 18. That should be possible because they have 20. So this one seems to be possible to me. That's because for the Stars to win 3, that would require 3 times 6, which is 18 votes. And they do have 18 votes, right? They have 20 actually, so they should be able to do that. All right. We should also look at these ones down here. Is it really possible for the circles to win all 5? By the same reason, you think in order to win all 5, you would need 30. And the circles, actually, they do have 30, so that should be possible also. So I think actually all the rest of them should be possible. All right? Because the numbers are appropriate for all the rest of them. This is the way you got to think about these ones. And this part of the problem has nothing to do with the picture. It's just about looking at the numbers and deciding, do these folks have enough to make it? Any questions about that? All right. Next part of the question is, can we draw the possible ones? So I said there are these 4 are possible. Let's try to actually draw the possible ones. And for this one, of course, you do need to look at the picture. Draw the possible ones, all right? I'll get the picture back here. They don't let me put the picture on the page break. Come on now. All right, I'll put it down here. Okay, you'll see on the picture, I did not evenly distribute the voters in terms of their, if you think of these as 2 political parties, they're kind of clustered. This actually is kind of realistic. In the real world, say the Democrats and the Republicans, they actually do have some kind of clustering. It's not like Democrats and Republicans are randomly, evenly spread throughout the country. They're not. Like I've said before, Democrats tend to be, people living in cities tend to be Democrats, people living in the country tend to be Republicans. White people tend to be Republicans, people of color tend to be Democrats. So this is not a random distribution, right? And so this map, of course, is completely made up, but it is a little bit more realistic in that I sort of clustered them up. Although these people are all living in a parking lot or something. I know people don't actually live in these locations on campus. I don't really know anything. I've been at Fairfield for a long time, but I don't ever go to the dorms. That's kind of a red flag, I would say. I stay in this building most of the time. Sometimes I go to the other academic buildings. I don't know much about the rest. Sometimes people tell me, oh yeah, I live in whatever. I don't even know the names of these places. I go to the Tully, like the building.
Okay.
I don't eat there. I have been there a few times, but not not typically. I bring my sandwich and I eat it alone at my desk. This is my lunch routine. And I like it just fine. Don't pity me. All right. Can we make this? So you're going to have to draw at least 4 different pictures. Like if you mess it up, I gave you several more on the paper there. Let's try, how about I'll try and do one, and then I want to see if you guys can try to do some of the other ones. Let's try to do, how about 1 star and 4 circles? I got a handout. Let's try 1 star and 4 circles. All right. Of course, there are many ways that you can make this happen, but my strategy, when I see like one of something and then everybody else goes to the other party, my strategy when I draw this circle is pack the one. What I mean by that is I'm going to make one district which is basically all stars or almost all stars, and then the other districts I will crack apart the remaining stars and try to split them up. So I see actually stars existing in these 2 parts naturally. Maybe I'll choose all of these guys to be my district. Now this, I have to have 10 people in each district. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, so this works out very nicely. I will make one district right there, packed full of stars, all right? And now I have to make 4 more districts in such a way that the stars don't win any of them, all right? So I pack the one, and then I will say I will crack the rest. These are the words that people use when they're drawing these, packing and cracking. I pack the one, the rest of them are right here, and I do not want to put those guys all together because then they'll win. I don't want them to win anymore. So I'm going to more or less, I mean, I don't know if this will work per se, but more or less split these guys into 4 separate groups so that they can't win anymore, and just add together some of the circles to each of those. Now I drew right straight through one of the stars, so maybe I will take, how about I will take these 4 stars down here and then put them together with 6 circles so that the stars will not win this district. I'll go sort of down and to the left here. 1, 2, 3, 4, 5, 6. Maybe those 6. Like I said, there are many ways you can do this. You don't have to do it the same way that I did. All right. So that's another district of 10 voters. Maybe I'll pick up the next 4 stars over here and again stick them with 6 circles so that they don't win. 4 stars here, and then 6 circles like that. How about those ones? Right? Sorry it's so hot in here. I'm feeling it. And then, I should be able to just divide these more or less however I want. The stars are not going to be able to win anymore because I cracked them up. That's the terminology. Anyway, here's 5 circles, and then I'll take these 5, 6, 7, 8, 9, 10. How about that? So like this, and then everybody else gets to be in that district. All right? Many ways to do it. That's how I did it. And I believe if I were to indicate, so who wins who? This one is a star, and all the rest are circles, right? There you go. That's how we do it. Any questions about that? All right, I would like to see if you can do the other options. So this was 1 star and 4 circles. Remember the other ones we decided were possible were these other ones. I did this one here. 0 stars, 5 circles, 2 and 3, or 3 and 2. All right, see if you can make it happen. How would you do 0 stars and 5 circles? That one you're going to have to try hard to crack all the stars. This one that I did was a little bit easier. You want to, in that example, 0 stars, 5 circles, you have to crack all the stars. I would suggest pick just 4 stars at a time and always put them with 6 circles, and hopefully that will work out. Try it out. I'll walk around and see how you're feeling. I also printed out some homeworks. Anybody need a printed out homework? You're going to want to print it for tomorrow.
Are we doing 2 stars?
2 and 3, yes. Yeah, that's.
Oh, no, I had something.
Yeah, this would be homework for last time. You gotta make weird shapes.
It's okay.
Yeah, that's one. Those are the 3 more possible ones that you should be trying to draw at this point. All right. Yeah.
Is this allowed? Can we have to do something?
No, that's allowed. Yeah,
Oh.
as long as there's 10 each.
Oh. Yeah.
Come on. I think it's like north is. Let's take a couple more minutes and then I'll try and draw my answers. I hope it's going all right for everybody. All right, let's talk about these, can we? So I think this is the easiest one to do, 2 stars and 3 circles, because the star populations, they live naturally in 2 little clusters, and if you just make those 2 clusters into their own districts, then the stars win those 2, and then you can pretty much divide everything else up however you want, and the circles will win all the other ones. All right, you just got to make sure you have 10 people per district. Any questions about that one? You should have made your picture more or less look like this. I mean, it's not required. You could have done something different, but that's the easiest way. Okay, 3 stars and 2 circles is kind of tricky because in order to get 3 star districts, you have to somehow combine some of the stars over here with some of the stars over here. My strategy when I was drawing this is to make the 3 stars by putting 6 stars per district, which is why I picked out 3 stars from this cluster and 3 stars from this cluster and tied them together in this somewhat weird way. And then I had to make my other districts sort of snake around in order to get, here I have all the stars are winning these ones and the circles are winning those 2. I hope you came up with something like that. Your picture does not really need to resemble mine, but you did have to play some trick where you take stars from each of these 2 regions. All right, and then the last one, 0 stars and 5 circles. Let's see if I can make it happen. Here I have to crack up all the stars. That means my strategy will be to make all my districts so that they have 4 stars and 6 circles. And hopefully this will all work out. So taking 4 stars and 6 circles, maybe I'll take these 4 right here, plus 6 circles would be like that. They're going to be very weird shapes that I end up drawing here. So that's 4 stars and 6 circles there. Next, I will take 4 of these and combine them with 6 circles. It's going to get a little nasty. I got those 4 and then maybe 6 circles. 1, 2, 3, 4, 5, 6 right there. All right. Okay, now this one is extra nasty. I have 2 stars over here are going to have to combine with 2 stars up here. So I'll take those 2 4 circles there. I need 2 more circles and 2 more stars, maybe like that. All right. All right. I'm doing 4 stars, 6 circles in each one. Here I have 4 stars there, plus 1, 2, 3, 4, 5, 6 circles, like so. And then finally, this one here. All right, I think I did it. Here are the stars. The stars lose every time because there's 4 stars and 6 circles in each one. Any thoughts about that? I hope you came up with something like this. Probably your picture doesn't look like mine, but it's if you want to make it work, it must have 4 stars, 6 circles in each one. All right. Great. This is all I wanted to say about how do you, if I show you a map, can you draw the districts to make certain outcomes occur? All right. That I will say the moral of the story is drawing the lines. Can I say drawing weird lines is very powerful, right? You can basically make the results whatever you want. Now, not exactly whatever. There are some impossible results, but within a certain within reason, you can cause very different results to occur without actually changing any of the voters' minds about anything. That's the moral of the story in terms of the real world. It is much easier to win an election by redrawing the lines than it is to actually change people's minds about the issues, right? Drawing weird lines is very powerful. In the real world, it's a little harder to predict exactly how people are going to vote. You know, this is all based on you. I'm imagining a scenario where you already know how everybody's going to vote, and then you draw the lines. Now, in reality, you don't really already know how people are going to vote, but you can do this very accurately if you just sort of take last year's election and assume that people are going to vote the same way by parties or whatever. You can actually do this with decent accuracy. In real life, people do this using computers, not by trying to draw weird lines by hand. And so this is extremely powerful in terms of influencing results of elections. All right. The big question that I want to talk about next is how can we detect if this is happening or not? How can we detect if the lines are being manipulated I would say for partisan reasons? And this is the more interesting question, I would say, like in terms of making our society better. I would say the people who are trying to draw the lines to fix the results in a certain way, those are the bad actors, right? They are the ones who are acting in what I would consider an undemocratic way, because you're trying to influence the election just by changing the technicalities of the lines rather than actually changing people's minds. The more important question for the good guys is how can you tell if somebody else is doing this? Yeah.
Do they actually keep changing these lines in real life, or are they like set?
Yeah. One solution to this in the real world, you could just say let's just not change the lines anymore ever. Like everybody maybe decide on a fair map once and then keep it that way forever. That is not possible because of the way that Congress representatives work. They're based on the population of the states. And so if one state increases its population, they get another one. And for instance, if Connecticut grew a lot, the next time they do the census, we would have to go from 5 regions to 6 regions. And you have to completely redraw everything then. So there is no simple way. Some people have suggested we should just make a law that all of the districts should be drawn by computer algorithms so that there can be no partisan manipulations. Which to me, that actually sounds like a decent idea on the surface, but it kind of hides the fact that somebody is going to have to create the computer algorithm, and the algorithm will be designed to have a certain type of output. You have to tell the computer, I want you to draw the districts to look like this or that. And then you are just shifting. Right now we have decisions about the district being made by individual people who sometimes have partisan motivations. If you make a computer do it, you are just shifting the decision-making process to whoever wrote the computer program, which is, I mean, still just, you're relying on somebody to kind of do it fairly. You just have to trust that someone is doing it fairly, and nobody trusts that anybody does it fairly. So this is the important question that I want to spend the rest of our time talking about for the next few times. How can you tell if the lines are being manipulated for partisan reasons? Like I said last time, these maps are often decided by courts. The U.S. Supreme Court has decided some of these cases where one party says the map is unfair to us, and they have to convince a judge somewhere that it's really unfair. And there needs to be some kind of measuring, right? How can we detect? What I mean specifically by this is mathematical measures, mathematical measures of gerrymandering, right? That's what I want to talk about for the next week or so. As usual, gerrymandering. As usual, there are many ways to do this, many different strategies that you could take that give you different mathematical measures. There's about like 6 or 7 that I have heard of that are used in the real world. We're going to talk about 2 or 3 of them in this class, but there are others as usual. There are two kind of basic approaches. One is you can try to measure geometrically how weird the shape is. Right? That sometimes is a red flag in terms of, is the map being manipulated by some kind of bad actors? If they're using really weird shapes, then this is a red flag in terms of maybe the map is somehow being manipulated. So, and there are mathematical ways to measure how weird a shape is, just geometrically speaking. Like a circle or a square is not really weird, but some kind of like octopus, squid-like shape is really weird. And there are actually mathematical ways to do that. We're going to talk about those kinds of things. And you can see, like, from that point of view, I would say this map looks very natural to me, whereas this map looks kind of crazy because I have very weird shapes like this, right? Anyway, that's one way. And then we can also try to, and this is actually where we're going to start, is this second one here, try to numerically detect packing and cracking. Specifically, packing is what we're going to look for. If you see a single district which is packed full of a single political party, whereas all the other districts are more of an even split, this is another kind of red flag that there has been some manipulation going on. Because that is a way, as we know, that's one way to make the other party lose, if you pack them all into one district and then spread them out in all of the other districts. And I actually had a real world picture to look at here. This is an extreme example of packing in the real world. These are the state representative districts in the state of Wisconsin. I think that's how they say it. I'm not from there. The state of Wisconsin. What you see here is the blue ones are Democratic and the red ones are Republican. And the color, like the darkness of the color, is the margin of victory. So you can see here, Madison, which is a city, is dark blue. That means this is, the margin of victory is the Democrats won very strongly. Actually, you can see in the very darkest color is they were running unopposed. So all the districts of Madison, they didn't even run a Republican against the Democrats because they knew they didn't want to waste the money, right? The Republicans really have no chance here. The city of Milwaukee also is solid blue, all right? This is not a surprise because, as I said, we expect the Democrats to win in cities and the Republicans to win in the country. All right. What is surprising are spots like this. This is not a big city. This is just like a little thing there, a little nugget of pure blue surrounded by slight red. All right. This to me looks like what's happened here is they packed one district full of Democrats, and then the nearby Democrats got distributed into these other districts, which are slight red. All right, that is, and the same looks to be happening right here, and also right here, maybe. And you can see that everywhere. Actually, if you look at this whole picture, in general, this is not always true, but generally here. By the way, these are the numbers from the 2018 Wisconsin State Congress. You know, every state has their own Senate and House of Representatives. These were the Wisconsin State House of Representatives. And I will say, you can tell just by looking at here, generally the blue districts are dark blue, whereas generally the red ones are light red. This is not always true. There are some dark red ones, but this is generally true, like overall. On average, the blue ones are quite dark, whereas the red ones are quite light. What that suggests is that the Democrats have been packed into those blue districts, and then the remaining Democrats have been spread out among the red districts. That's why there are not a lot of dark reds. There are a lot of dark blues. At least that's what it seems to be. All right. And if you look at the numbers here, actually, I will tell you some statistics here. 53% of voters in Wisconsin in that election. This is 2018. 53% of voters in Wisconsin voted for Democrats. That is the blue. It was 53% voted for the Democrats, 47% of people, of individual people, voted for the Republicans. But in the final analysis, the representatives, when they counted up all the votes, the representatives were 63 Republican and 33 Democrat. All right. Most of the people in the state voted for Democrats, but they got absolutely destroyed in the election, right? 2 times as many Republican representatives. That's because most of the people voted for Democrats, but most of those people who were voting for Democrats were stuck in these districts that were basically like 100% Democrat districts. And so that's far too many. All those votes, like most of these people, could have been winning other districts, but they were packed into the same districts with one another, all right? So this is a classic example of a super packed map in favor of the, here the map favors the Republicans because the Democrats are all kind of living together, voting for candidates who are unopposed, and their votes are not counting against all the Republicans who are winning in the country. All right. I hope that it seems to you that somehow you could imagine like doing some kind of mathematical analysis of these numbers here to demonstrate that something fishy is going on here, just by looking at all of these kind of statistics here. And that's the kind of thing that we're going to try to measure. So what I want is we have a way of measuring if, I will say, many votes from one party are packed together. This is not even, it's not hard to do. I mean, when you do it like by hand, it takes a while, but if you're using a computer or something, this is a very simple kind of analysis to do. A way of measuring if many votes from one party are packed together. The reason why you care about this is because lots of those votes are the terminology that they use is wasted. We are counting up wasted votes. The reason that packing ends up wasting people's votes is, like, if I'm in an evenly split district and I'm voting for the Democrat, my vote matters a lot. Whereas if I'm in a district which is like already 90% Democratic and I'm voting for a Democrat, then my vote is more or less irrelevant, right? And if I can vote for the Democrat, but my vote is essentially wasted in that situation. So voters inside of packed together districts are wasting votes because those votes don't really matter as much as they would have if those same people were in other districts. All right. The method for measuring this kind of thing, this is counted or measured by what we call the efficiency gap. The efficiency gap is a way of counting how many votes are wasted by the Republicans because they were packed, how many votes are wasted by the Democrats because they were packed. And then if one or the other parties is wasting far more votes than the other one, then you can conclude that some kind of funny business is going on with the maps. That's the idea behind the efficiency gap. All right. Any questions about that? We're going to do some real numbers, some real examples here. But this is the basic idea here, the efficiency gap. All right. Let's try a specific. I'll give you some definitions here. All right. So what it's all about is counting up wasted votes, all right? And here's the definition of a wasted vote. A vote, well, I'll just say a wasted vote is one which doesn't contribute to the winner's win. This is actually kind of a tricky concept. You'll find yourself getting a little bit confused about this when it comes to doing the homeworks. A wasted vote means it's a vote which doesn't contribute to the winner's win. Now, you have to think about this in terms of people voting for the loser. In this sense, all of those votes are wasted because their guy didn't win, and so they are not contributing to the winner's win. So any vote for the loser is wasted. Any vote for the winner, well, some of the votes for the winner do actually make them win, but there might be lots of extra ones, and those are wasted. So I'm going to say any vote for the winner beyond the threshold is wasted. That's because, if you only need 5 votes to win, but you get 15, it's like 10 of those were extra, and you didn't really need those, right? Those voters could have had a bigger effect in a different district, so they are counted as wasted. So any vote for the loser is automatically counted as wasted. Any vote for the winner beyond the threshold is counted as wasted. All right? Yes?
What would a wasted vote be in ranked choice voting system?
We don't really talk about wasted votes in those kinds of ranked systems. This is always about if you just have 2 candidates and everyone is just voting for one or the other. Yeah, you can. I believe you can talk about this concept in other settings, but it's not typically done, and it's certainly not what we're going to talk about. All right. So, for example, let's just simple example in, let's say, a district with 100 voters. Let's say the D's get 47 and the R's get 53. All right? In all these examples, I'm usually just going to talk about D's and R's just because that's more convenient. How many votes from each party are being wasted? How many are wasted? Well, what I said before is any vote for the loser is wasted, any vote for the winner beyond the threshold is wasted. So first of all, we should decide who is the winner. Well, I said 47 for the D's, 53 for the R's. So the R's is the winner. Maybe I'll circle that. I will say the D's all voted for the loser. So they are all wasted. Right? So the D's wasted 47 votes. What about the R's? Remember the rule, you can still see them on the top there. Any vote for the loser is wasted. Any vote for the winner beyond the threshold is wasted. So we have to think about what is the threshold necessary to win in this example? Yeah, the threshold here is 51. That's how many you need to win if there are 100 voters. So the way you figure this out is you always do something like you divide the number of voters by 2, and then you go plus 1, or maybe you round it up. If the number of voters is odd, you just divide by 2 and round it up. All right, so the threshold is 51, so the R's wasted how many? 2, yeah. They had 2 extra votes. So in this situation, the D's wasted a lot more than the R's, just because the D's lost. Like this arrangement here does not seem unfair to me. You could say the D's wasted a lot more than the R's, but that's because the D's lost. So in general, you expect the losers waste a lot. The winners don't waste that much. But if it's packed, then these numbers are totally different. If it's packed, then if the votes went something like 20 to 80, then the D's would have lost only 20. They would have wasted only 20, whereas the R's would have wasted 30. All right, and this is evidence that the R's are wasting a lot more than the D's. Even though they won, that shouldn't happen. So this is how the efficiency gap is computed. You look at all the districts. Here, let's just do another extreme one. How about what if it was D gets 97 and R gets 3? All right. In this case now, the D's wasted, the R's wasted. How many did the R's waste? 3. Yeah, the winner is the D, and every vote for the loser is wasted. So the R's wasted 3 because they were the losers. Every vote for the loser is wasted. The D's wasted, the threshold here is 51, remember? They got a lot more than 51. I believe 46 more than 51, right? This came from doing 97 minus 51. The threshold was 51, but they got 97, all right? So what you can see is, the moral of the story here is, in an even district, the loser wastes a lot, the winner wastes a little. That was the first example that we did, right? If the district is more or less even, that was like 47 to 53 in the first case, the loser wastes 47, the winner wastes only 2 or 3, right? That was the first case. So in an evenly arranged district, the loser wastes a lot, but the winner wastes a little. But if the district is packed, like this one here, actually the winner wastes a lot and the loser wastes a little. It's the opposite. And this is the way you can, by counting up who is wasting more or less, you can tell if the districts have been packed or not by this fact. So if it's even, the loser wastes a lot, the winner wastes a little. But in a packed district, it's the opposite. And this is what we're going to be able to detect just by counting up the wasted votes. The loser wastes a little, and the winner wastes a lot. All right, so we can tell the difference just by counting up wasted votes. We can tell the difference between a packed district and a more even district. All right. Great. I got, let's just try a specific example of exactly how to do the efficiency gap. It's not hard to do. It will take you a few minutes. It's kind of like, I mean, it's when you're doing it, it's not anything like the Shapley-Shubik or that kind of thing, but it's similar in that it involves a lot of stuff you got to do, but it's not hard to do it. You just got to do it. So I would like to do actually one of the examples that we had, one of the grids that we had from last time. I don't know if you still have this picture. It's not so hard to draw though. This was a grid which was 5 by 10. Let's see if I can do this. 1, 2, 3, 4. And it was like once the kind of left side here were slightly darker. All right, remember this one? This was a handout from last time. It's fine if you don't still have it, because it looks like that. You can draw it yourself if you want to. Let's try to divide this into some districts and then measure the efficiency gap. It's about who's being packed more than the other one. So I'm going to make, I believe this was like one of the first example divisions that I made of this. Was like that. All right. These are 5 districts from that rectangular grid example. And I'm going to, just for the sake of writing everything down, I'm going to number these districts 1, 2, 3, 4, and 5. All right. And in each district, we're going to decide how many of each party wasted their votes in each little district. So in each district, we count come on, the wasted votes. And I'm going to call them D versus L, the darks and the lights, all right? In each district, I'm going to count how many were wasted every time. And I'm going to do this by making a chart. You know, some of this you might be able to do without writing a big chart like I am, but we might as well. I'll bring this down here. I hope I can fit this without scrolling. So I'm going to make this chart. So it has districts, D's, and L's. So first of all, I'm just going to count up the number of votes. I'm going to have, this chart eventually is going to have 7 columns in it. So you might want to write it down below. I'm not going to be able to fit it in if I don't want to scroll away. But anyway, there are 5 districts. 1, 2, 3, 4, 5 districts. And I'm just, first of all, going to write down the votes from each party. So in District 1, I have 4 darks and 6 lights. All right? 4 darks and 6 lights in District 1. In District 2, I again have 4 darks and 6 lights. I'm just counting up how many of each voter is in which district, in each district. In District 3, it looks like 2 darks, 8 lights. District 4 is 0 and 10, and District 5 is 10 and 0, all right? So this is just recording the votes. Now actually after this point you don't need to look at the picture anymore. Everything now is based on these numbers, so now I will scroll away from the picture. All I did to start off the table though is just count up how many of each symbol are in each district. Okay, the next column in here is going to be easy to do. It's just the total per district, which is 10 every time. Now in the real world, we're going to do some more realistic examples. In the real world, the districts are meant to have roughly equal populations, although they don't have exactly equal populations. There are some rules about the populations have to all be within, 1% of each other or something like that. You can't make them exactly equal in the real world just because you don't know exactly who lives everywhere. Anyway, each district has a total of 10 people. And then for each of these, I'm going to write down the threshold, the threshold to win in each of those districts. So each time you're looking at 1/2 of the population plus 1. And in this example, it's going to be 6 every time, right? That's how much you need to win in that district. All right, all of this is just routine. Here's the important part. I'm going to write down the D wasted and the L wasted. How many votes are the D's wasting versus how many votes are the L's wasting in each of those districts? All right, and this is the hard step, I suppose. Maybe I will first, just to help us out, I'm going to circle the winner every time. Because remember, deciding who is wasting depends a lot on who wins, right? And the rules are every vote for the loser is wasted, and every vote for the winner beyond the threshold is wasted. So maybe I'll write down first the votes for the loser, because every vote for the loser is wasted. That means in the first row, the D's wasted 4. In the second row, the D's wasted 4, and then 2, and then 0, and there's a 10 over here. All right? First, I write down, just because I don't have to think to do this, every vote for the loser every time is always wasted. So those are all the votes. The last column there is a 0, not a 10. Sorry about that. There were 0 votes for the loser that time, right? Now, this is the more interesting part. I'm going to write down every time about the winner. How many did the winner waste? So in the first row, the winner got 6. The threshold was 6. So how many are wasted? The answer is 0. They had none extra above the threshold. And so the L wasted 0 that time. No extra votes above the threshold. That's what it takes to be wasted. All right? In the second row, same situation, right? They got exactly 6 votes, which is equal to the threshold. There were no wasted votes from the winner in that one. What about the next one? They got 8. The threshold was 6. So how many are wasted? 2. Yes. In the next one, they got 10. The threshold was 6. That would be 4 wasted. Yes. And in the final row, it's the D's who won this time, but same idea. They got 10 votes. They needed 6. That means 4 were wasted, like so. All right. This is, I suppose, the hard part. It's not really hard. You just got to make sure you understand what exactly you're looking for and write down the wasted votes for each of the 2 parties. All right? We basically finished the business. We just have to sort of report the answer. So the way that you write down the efficiency gap is I'm going to add these up because we intend to compare which party wasted more votes. All right? So the L's wasted 6 total, and the D's wasted, that looks like 14 to me. So the D's are wasting more. That means that it seems like this arrangement is benefiting the L's, right? The D's are wasting more, and so the L's are being helped by the map in this case. Now, specifically, the efficiency gap is reported as a single number. The other thing that you do is you add up the total number of voters, which in this case is 50, and I say the efficiency gap which I will always from now on write EG, efficiency gap, is, it's a fraction, which is basically like the percentage of wasted votes that are wasted by one party more than the other. Anyway, here's what it is. It's 14 minus 6 divided by 50. So the D's wasted more than the L's. How many more? Actually, 8 more in this example. That's what this is on top. 8 more votes are wasted by the D's. And they divide by 50 just to turn it into a percentage. All right? So this is 8 if you wanted to simplify. I don't care if you simplify. 8 over 50, which if you actually divide this out is 0.16 repeating, which is 16.6%. All right? And we say this is the efficiency gap, 16%. That means the D's are wasting 16% more than the L's, right? Both of them are wasting some. It's just that the D's are wasting that much more. And we say the efficiency gap is 16% in favor of the L's. This is an important part of the answer, all right? So the efficiency gap always consists of a number, and then you say in favor of somebody or other. The D's are wasting more, and so this is in favor of the L's. Yeah.
Isn't it exactly 16%, not
probably 60.
Is it? Oh yeah, 8 divided by 50. Yes, it is. Thank you for that. Yeah, this would be like 1/6 is 16%, but that's not what that is. 16%. That's what it says on my paper. I just wrote 0.6. Thank you. All right. He knows his percentages better than me. It's true. You know me well enough to know that I don't really care about this part. This is what I care about right here. 14 minus 6 over 50. All right, in favor of the L's. This is how you find the efficiency gap. So this suggests that that map is packing the L's more so than it is packing the D's. All right. Any questions about that? I got another example to try. How about, we got 15 minutes? We can do at least one of these. I have a handout with 2 more examples on it. I don't know if we'll get through both of them. How about I'll do one, and then you all can try the second one. Maybe I will, can I take a moment to make an announcement? I meant to say this at the beginning, but on, I don't know if this sounds interesting to you, but on Thursday, I am giving a talk. Thursday, 1 p.m. in the library, like the basement room in the library. And if you come at 12:30, you can get some pizza. Lunch is included. Maybe 12:45, something like that. I'm giving a talk about I don't know if you know this about me. This is I have a collection of antique mathematical computing instruments, and I'm giving a talk about 4 different historical instruments for measuring lengths and areas of pictures, like on a piece of paper. If that sounds interesting to you, come on by, check it out. Get the pizza. Don't take the pizza and then leave. You got to stay for the talk. It should be interesting, and I'm going to bring some little gadgets that you can play around with. If that sounds fun. I don't think you get the FYE credit for it or any of that. I don't know anything about that. All right, let's look at the paper here. So I would like to look at the first example there, which I have a picture of here. We probably will not get to do both of them. Maybe we'll start off next time doing the second one. All right, here is a very natural looking division. Actually, if you just look at the 2 examples on the paper, just eyeballing it, it looks to me like the first one is more natural, whereas the second one seems to be packed. Like I can see District 1 in the second one looks very artificially packed to me, all those dark ones all together. But anyway, let's see if we can find the efficiency gap here. All right. So I'm going to make like a big chart like I did before. So I'm going to start with my districts. There are 4 of them. And then I have the D's and the L's, just counting up the votes in each one. So this, unfortunately, you got to like count up all the dots, right? So in District 1, I have 1, 2, 3, 4, 5, 6, 7 light ones. And there are 16 total here, so there must be 9 D's. All right? I am just counting out. D is for dark, L is for light. Okay? That was District 1. District 2, we have 1, 2, 3, 4, 5, 6, 7 lights. Again, 7 lights and 9 darks. All right? District 3, if I count the darks, it's 1, 2, 3, 4, 5, 6, 7. This is 7 and 9 like that. And then District 4, if I count the darks, it's 1, 2, 3, 4, 5, 6, 7. 7 and 9 like that. All right? Did I count them all right? I think so. Nobody's complaining. So, all right. After this, you don't need to look back at the picture anymore. The rest of the table is just filled out based on those numbers. So, first of all, I'm going to write the totals, which is 16 every time. Again, on a typical made-up example, these will all be equal, but in the real world, there might be slight differences from one total to the next. And just because I know we're going to have to do it, you should add these up, and I get 64 if you add up all those 16s. All right, and then I have the threshold every time. What's the threshold in 16, if there's 16 total? What do you say? 9. Yeah, half would be 8. One more would be 9. So the threshold every time is 9. You don't have to add up the thresholds. That is irrelevant. All right, and now I can decide D wasted versus L wasted. All right, again, I'm going to first indicate who was the winner because that makes a difference in terms of how you figure out who is wasted or not. All votes for the loser are wasted. So all the 7s are going to be wasted for whoever it was. So in the first row, the L weighs 7. In the second row, the L weighs 7. In the last 2 rows, the D's weigh 7 each time. All right? And then any votes for the winner beyond the threshold are wasted. And so the winner of the first one got 9. The threshold was 9, and so they were 0 wasted in that example. All right? District 2, also 0 wasted. And District 3 and 4, actually, the winners are wasting 0 here. Nobody is ever going above the threshold, all right? That, to me, indicates there's not a lot of packing at all. Nobody is packed over the thresholds. Okay, let's just finish the answer then. You add these columns. I think we will have time to do both of them. I'm going to do both of them. You add those columns together. And your answer is, the efficiency gap is, remember how you make that fraction? It's these two numbers subtracted from one another, the bigger one minus the smaller one, divided by the total number of voters, which is 64. All right? This usually doesn't happen, but you get 0 this time. 0 on top. 0 divided by 64 is 0. All right? This would indicate in terms of the efficiency gap, districts which are perfectly fair. This never happens in the real world. You always get some amount of efficiency gap, but this means there is no advantage to either of the parties because the efficiency gap is straight up 0. All right? Any questions about that? This is just sort of coincidental that you get 0 on the nose. In a real scenario, you would never actually get 0. All right? Let's try the other one. The other one looks to me, like I said, at least just kind of eyeballing it, it looks much less fair than that first one does. So here, I am going to, again, begin by counting up in each of the districts. I got 4 districts. 1, 2, 3, 4. D's and L's. All right? I hope everyone remembers. So you got to count. In District 1, I will count the L's because there's 2 L's, and that means there's going to be 14 D's. Right? In District 2, I see 1, 2, 3, 4, 5, 6, 7 darks, which means there should be 9 lights. In District 3, over here, I see 1, 2, 3, 4, 5, 6 darks, which means there will be 10 light. And in District 4, I see 5 darks, 11 lights. All right? All you got to do, you just count them up. Okay, next, I do all of this business. So the totals here, again, are 16 every time. The threshold, again, is 9 every time. And the important part is the D wasted, the L wasted. So the winners, I will circle each time. I find this helpful. You don't have to if you don't want to. In the first row, can anybody say how many is the D wasting? 5, yeah. The threshold is 9. The D's got 14. That's 5 too many. So the D's wasted 5. And the L's in the first row? 2. They were the losers, and every vote for the loser is wasted. So the L's wasted 2. All right, in the next row, the D's lost, and so all the D votes in the next row are wasted. That's 7. How many for the L? 0. Yeah, they got exactly equal to the threshold. None extra. All right, in the next line, 6 votes for the loser are all wasted for the D's. And the L's got 10. The threshold was 9. That's 1 wasted. And then in the last line, the D's got 5, all wasted. The L's got 11. The threshold is 9. That's 2 wasted. I hope everybody sees how I'm getting those numbers. All right, so my final answer, you got to do some adding. Add 2 and 1 and 2 is 5 wasted total for the L's. For the D's, it's 10 and 7, 23. And the total is 64. And so my final answer is the EG is 23 minus 5 over 64. And I did the numbers on this. This is about 28%. You got to say in favor of. Who is this in favor of? L. Yes, L is wasting fewer. D is wasting more. So this map benefits the L by to the tune of 28%. All right. This is the efficiency gap. Very nice numerical way of specifying who is wasting more votes. All right, that'll do it. Do that homework. I'll see you all next time.